In wave optics, we have the topic interference due to a thin films by reflected system. To explain the interference phenomena using the thin films, here we can choose the rectangular glass plate. Its thickness is T, refractive index is mu. Have the two surfaces. Upper surface is named as XY and lower surface is RS. Here we consider the ray of light AB in rarer media whose refractive index value is 1 is incident at a point B on the upper surface of XY. The angle of incidence is I. BC is the reflected ray making the same angle of incidence. Here the angle of incidence is equal to angle of reflection. That's why here I can put it as the same symbol I. And BD is the refracted ray which can be traveled throughout the denser media. Incident lower surface at a point D, immediately it can be reflected DE, and EF is the refracted ray. Here also making the law of reflection, the angle of reflection, here we can put it as R, and incident is also we can put it as R because here also law of reflection is applicable. The angle of incidence is equal to angle of reflection. Now, to exhibit the interference phenomena, the rays BC and EF, we must maintain the coherence condition. For that, I can draw the normal line on BC. To eliminate the BP value, then only those two rays appears coherent. To observe the diagram, to eliminate the path difference BP, then only those two light waves appears coherent. First and foremost condition is to exhibit the interference phenomena, the two light waves are coherent. So we can draw the normal line on BC, that BP is the path difference. We eliminate that path difference, then the two light waves appear coherent. Now superimpose one over the another. Focused on the screen at any point, we can see alternatively bright and dark bands. Now how to find the path difference? We can apply the formula. Path difference delta is equal to optical distance minus BP. Optical distance in the sense the distance traveled by light in denser media. Here glass is the denser media of refractive index mu and BD plus DE minus BP. How to evaluate the values of BD and DE? Here we consider the triangle BQD. Consider the triangle BQD. Choosing the angle cos. Why we can choose the cos? We know the value of adjacent side value. How to determine the hypotenuse value? So we go through the cos. Cos R is equal to adjacent side by hypotenuse. Then dq by BD is equal to T by BD. Then BD is equal to T by cos R. Similarly, we have to calculate the DE value. Consider the triangle DQE. How to determine the value of DE? We can choose the angle, same angle cos R is equal to adjacent side by hypotenuse dq by DE. We know the value of dq, that is T, thickness of the film, T by cos R. Then we get the values of BD and DE. How to evaluate the value of BP? Here we consider the triangle BPE. That BP is just opposite side of the angle, so we go through the sign. Sin I is equal to opposite by hypotenuse. BP is the opposite side and BE is the hypotenuse of the triangle BPE. BE is nothing but BQ plus QE. Then BP is equal to sin I into BQ plus QE. Again we have to evaluate the value of BQ and QE. Consider the triangle BQD. Again we have to calculate the value BQ and QE. Here we consider the triangle BQD. We have to evaluate the value of BQ. It is just opposite side. BQ value and have the know the value of adjacent side, then we can take the value of tan. Tan r is equal to opposite side by adjacent side. Then BQ by DQ. BQ by DQ. We know the value of DQ, that is T. Then BQ is equal to T tan r. Similarly, QE value also same. Consider the triangle DQE. DQE. We have to find the value of QE, opposite side of the angle. We know the adjacent side value. That's why we can take the tan. Tan r is equal to, in a triangle DQE, tan r is equal to QE by DQ. Then QE is equal to T tan r. Finally, we get it the values of BQ and QE values. We substituting the values. Then we get it as sin I into 2T tan r. These whole values are substituting in path difference equation. Delta is equal to mu into BD plus DE minus BP. We get the values of BQ and DQ value. T by cos r, T by cos r. We substituting the values, and minus BP value also. According to Snell's law, we know that mu is equal to sin I by sin r. Then sin I is equal to mu into sin r. Now in this equation, we have delta is equal to mu t cos r minus 2t tan r. In place of sin I, we can put it as mu sin r. Then simplify the equation. 2 mu t by cos r minus 2t. Tan r can be written as sin r by cos r, mu sin r. Then finally 2 mu t by cos r minus 2 mu t sin square r by cos r. We have to take in the value of 2 mu t by cos r as common. 1 minus sin square r. Nothing but 1 minus sin square theta is equal to cos square theta. Here we can put it as that value. Finally, we get it as delta is equal to mu t cos r. Plus or minus lambda by 2 means here the ray of light is traveling from rarer to denser media, changing its path value. That's why we can put it as plus or minus lambda by 2. Coming to the cases, in interference we can put it as constructive and destructive. Constructive case is delta is equal to n lambda. Here the path value is 2 mu t cos r plus lambda by 2 is equal to n lambda. Now we getting the value 2 mu t cos r is equal to lambda by 2 into 2n minus 1. Dark conditions. Destructive case, path difference is equal to n plus r minus 1 into lambda by 2. 2 mu t cos r plus lambda by 2. We can choose as plus 2n plus 1 into lambda by 2, multiplying the lambda by 2 with the 2n plus 1. Finally, we get it as 2 mu t cos r is equal to n lambda. This is the interference due to a thin films by reflector system.